explain before I start. So when you look at SQL as a language, what you actually begin to look at is if you are speaking a language, then there must be the way communication works is you speak, and then what you're speaking is what somebody else understands. So the person that you're speaking to necessarily has to understand what you're speaking, and then when the person understands it, then the person can reply you. Is that what usually happens, everybody? Is that what happens? Of course, when you speak. So even if you are, and I think you'll find a more relevant example, if you probably speak Yoruba or Igbo and you're trying to speak to somebody in a language the person doesn't understand, what you find that happens often is you are speaking, but you are not communicating, because what you're trying to say, the person you are trying to say it to does not understand what you are saying. So the person cannot respond appropriately. You understand? So if I was speaking probably Igbo now, and then I'm speaking Igbo to an Hausa man that does not understand Igbo, you understand? The person looks at me like, what are you saying? And even if I was telling the person that somebody is after my life and they want to kill me, the person doesn't understand the language enough for me to respond, probably offer help or do something. So now I've tried to understand what languages and how communication works. You'll find it relevant when we move forward. Now, for you now to communicate properly to somebody, the person, we've said the person has to understand what you're saying. The person, that makes the person gives you a reply that you now understand, and then that's how communication will work. The same thing applies to SQL, because SQL is a language, and when you are speaking SQL, you have to speak it to something that understands it. Now, what understands SQL now is what is now going to reply you back. Now, your response now is going to be dependent on how understandable what you are saying is and how well the person you are saying it to understands it. You understand? So if I speak Yoruba very fluently, and I speak the conk one, not the one that you can speak anywhere, you understand? You find people who cannot understand it. I'm sure some of us that even go to our villages, you understand, maybe for holidays, we hear them speak maybe Hausa or Igbo or Yoruba languages, and when they start speaking, you ask yourself, is this the same Yoruba I am speaking, or Igbo or Hausa? So even while you could communicate with them, the responses you are going to get out of them would not be the same because you can't communicate properly with them. Now, this brings us to syntax. We have not started the slideshow. Just bear with me. Let me just speak for now. Now, this brings us to syntax and semantics, as you have it in probably English language or French or German, just basically linguistics. So for any language, there is syntax, there is semantics. Now, syntax is how it is arranged. If I was speaking English to you right now, and I am speaking English to you, obviously, the way I am arranging my words is syntax. I cannot say she went. Now, she went is English. It's English language. Basically, yes, we will all agree she went is English language. However, what you would find out is she went is not grammatically correct. Although it is English language, it does not conform to the rules that guide the way the language is being spoken or written. Are you guys with me? Have I lost you? Have I lost anything?
No, we are following you.
Okay. Okay. So because it does not conform to the rules of the language, in as much as it is the language, it does not conform to the rules of the language. That makes it non-conformant. And because it is non-conformant now, if you were to speak this she went to probably someone you are trying to communicate to in English language as part of a full sentence. Now, the person will be in accents to you because while she understands that she went, she does not understand the context of she went. Where did she go? She doesn't know. She only knows you said she went. Now, because she has said she went, now she can begin to think about a lot of things that happened while she would go. But she doesn't know any other thing aside what you've spoken to her. Now, bear in mind, we've talked about a lot of things. We've talked about language, we've talked about communication, we've talked about syntax, and we've talked about semantics. Are you guys with me, please?
Yes, sir.
Okay. So the way language works is you have to have somebody that understands what you're saying. What you're saying has to conform to certain rules, certain standards. And then the person has to also, for there to be communication, if you are saying it has certain rules and certain standards, according to you, it must also have the certain rules and certain standards according to the same person. So there is a baseline. And that is why Nigerians need to write IELTS when they are looking for admission in UK. I hope you understand why now. Hello?
Yes, sir. We are trying to follow you, sir.
Okay. And the reason why Nigerians will keep on writing IELTS is, in as much as we say we speak English language, and they agree we speak English language, our English is not the same as the one they are speaking. It is different. So now, what is SQL? SQL is a language. SQL is a language that you use to communicate to what we call databases. So we now start our lesson, databases and introduction to SQL, lesson 1. So what is data? What is a database? Let me start that way before we see what is big data. We'll start from what is a database. A database is, how do I put it? It is a database. I would say a database is a warehouse of data, you understand, which comes from different sources that identify different sources about an entity. So when we say a database, it is a place where we store data. And that data we are storing now is about something. And it could be about a lot of things. But in this case, let's say we just limit it to something. So for an example now, let's say you are a student. For most of us here that have been students or are still students, you would go to the university and then your school has an online portal and then you will register the courses you want to do. Now, all those information you are putting there, you are putting it into a database. And the information you are putting into that database is about you as a student and about the courses you are studying as a student. Are you guys with me?
Yes, sir.
Okay. Now, databases are put inside what we call relational database management system. Now, the word relational here is key because we also have some databases that are not relational. We are not going to delve into them in this course, but we talk of those kind of databases as NoSQL. We call them NoSQL databases. And some of them, well, we are not touching them, so we just talk with what we have here. So when we say it's relational, when we say database is relational, it means that what is being stored about things, which is data now that is being stored about certain things now, they are related. So that is the data being stored is not haphazard. So for a student now, a student is going to have, let's say a student that goes to school to study now, you would have a matric number, You would have your name, your sex, your department, your faculty, you have all those things. And then you'll be studying courses. So your personal data is linked to the courses you are studying. The courses you are studying are linked to lecturers that are taking those courses. And because the courses you are studying are not only courses for your faculty or your department or college, as the case may be, you also have those courses linked to departments, linked to faculties, and in turn now linked to lecturers that will be taking you those courses. So you have everything joining to each other. So if I want to know what course someone in 300 level studying maybe plant physiology is taking, I can speak the language SQL to the database that contains the school records or registration records of students that are in that school. And then by speaking that language to that database, I am now able to pull out data. Exactly the data I want, data about students studying plant physiology in 300 level. Are you guys with me? I hope I've not lost anybody yet.
Please write down, sir.
Okay, I've not lost you guys yet, I hope.
No, sir.
So what is big data? Now, because the world is now so very much connected, when you press your phone, you use data. Okay, someone raised their hand. You can ask a question, please. Someone raised his hand just now. No, nobody did.
Maybe it was a mistake. Yeah.
Come again?
Maybe it was a mistake. You can go on.
Okay. So now, because the world is now so large, when you do anything, a like on Instagram, a like on Facebook, a tweet, a chat you send to somebody, you like the person's picture, you sent a message, you interacted with an ad, all those sources, all those things you have done are opportunities. But basically what you have done is you have generated data about something. If you like someone's picture, you have told, let me not use the word picture, let me use an advert. If you like probably a commercial, maybe on YouTube, on Instagram, what you've done is you've generated data. And you'll find out something very interesting, that if you like maybe like 2 or 3 of something like that, you find out that scrolling down on your feed, you find out that you now begin to get things that look like what you have liked. I don't know. Maybe you go on Google. I don't know if you've noticed it. You go on Google and maybe you search for a shoe. And then maybe you just scroll around. You don't want to buy one, but you're just looking at shoes. And then the next thing that happens, the next time you go on a website that has an ad link, is you'll find pictures of shoes similar to the ones you liked before. And what has happened is you have generated data, and the data you have generated is what is being used to give you ad. And now we are in the world of big data, because the data we have now is generated by a lot of things. It's not just you going to school to register courses. What you do on Instagram, what you do on Twitter, what you do on Reddit, Pinterest, Facebook, all those things are data. And all those data need to go to a place, which is either a relational database or a non-relational database, and all those data can be interacted with. You understand? And it is on this data also, when you start doing machine learning or you are doing data analytics, that you are going to work to answer questions like what, why, when, how. You understand? Okay, so that is big data. Now, basically, you have all of this, and then you are generating all of this from you posting, taking notes, wearing a wristwatch that monitors your heartbeat. You generate data. So data is all around us. And because it's all around us and we generate it every day, you understand, it's big data. It's big data. Okay, so information, basically, when we say big data, we have like 5 V's. We have veracity, we have velocity, we have volume. And then I think two more. But basically, when we are talking of big data, we are talking of an huge volume. It would come in basically what you call structured and unstructured. When we say structured, we are mostly talking about the relational side of it. That is relational databases. And then you talk about things like your PostgreSQL that you have installed, like Oracle, like SQL Server, like SQLite, and all those other things that you would be interacting with. That is still the world of structured. Now, when we talk about unstructured, we are talking about data that is not structured. They are not relational. I think relational might not be the right word, but we are talking about data that does not have a structure. So you're talking about your video files, you're talking about your voice notes, your pictures, and things like that. You're talking about sensor feeds, things like that. That is what we call unstructured data. And then the repository or the database, all these ones are going through. You have things like Cosmos DB, you have things like LakeGen 2, you have things like MongoDB, CockroachDB, and names like that. But we are not delving into that today. So all this data you have comes together. And what it comes together to do is it comes together to give you insight. Because you have all this data coming together, you capture them, and then you capture them from different places. But once they are captured, they are collected together in a place. They come towards giving you insight into one or two things. To give you an example of what could happen, basically, in the process of this, we have, okay, let me go back to this. So let's say you decide to take a note of how much you spend every day and what you spend it on. You understand? So you write what you are spending down. And then when you're writing it down, you're writing it down in a place that does not get lost, not in a place that you get to lose it often. And once that is done, the next thing you now do is maybe after a month, you now begin to look at, okay, today I bought X and tomorrow I bought Y. And then you now, from that data you've gotten now, begin to look at, oh, what did I actually buy? How much did I spend on X? How much did I spend on Y? How much did I spend on Z? And now what you have done is basically you have captured data, you have stored it, and you have analyzed it. That's all you've done in simple terms. You have written down what you are spending money on. What you have written down in a place where it does not get lost, a place where you can always put more of what you are doing. You have put it there. And now, after a while, what you have decided to do is you have now decided to now analyze, understand the data that you have stored. And this is the process that will almost always occur when we talk about data analytics and things like that. We will always have data being captured from different sources. Now, in the process of capturing, there is what we call ETL, which is extract, transform, load, or extract, load, transform, depending on what you are using or the paradigm you are using. And then when you do that, you are storing the data in a database, you understand? And after you do that data, put it in a database, then you are now analyzing the data you have collected. And when you analyze the data, we talk about the what, the why, the how, and the when. And then we also talk about different types of analytics. We talk about it being prescriptive, being predictive, and things like that. I hope I've not lost you guys. We are just doing general introduction. We're not doing any heavy lifting. I hope I have not lost you guys, please.
It's good, sir. Thank you. We are moving into, sir.
Okay, thank you, sir. Okay, so so when we store databases, or all of this has gone into a database. So let's say this is our database. Let's say this is our database. This is actually our database. All our data that we have captured, we are storing it here. Now, you will remember when I first started, I said, when you are speaking a language, there should be something that understands the language you are speaking so that you can get a response. And the response you would get is going to be dependent on how well the thing you are speaking to or the person you are speaking to understands what you are saying. Are we agreed on that?
Yes, sir.
Okay. So in this case here now, what we have here in this diagram is we have SQL as a language interacting with this fellow here, which is our database. And what it is doing, you see that this is a two-way operation. We have lines coming from SQL going to this database and lines coming from this database going to SQL. So it's a very iterative process. And I'm just going to say this in case I forget to say it. When you begin to write SQL, you are not going to write queries that run. What we write in SQL is called queries. You understand? But just like when you start learning English language, you are not going to be able to, at the first try, make very grammatically correct sentences. And if you look at how long you've studied English, you studied English in your primary school, you studied English in your secondary school, and even when you got to university, you studied English. So give or take now, you studied English for 13 years or 14 years, and you still keep on using English language. The person doing that should please stop. Okay. You now have, you studied English for like 15 years, and you still use English. Until date, you'll find out that when you still write English, or when you still write English language, you still find out that you still make mistakes. So the same thing is applicable here. At first try, your legs are going to be wobbly, just like a new kid that is trying to run, you understand? But as time goes on and you keep up trying to run, what will happen is your legs get stronger and you know how to run better. And that is why this is an iterative process. So you write what we call queries, which is called SQL language, and then you send it to this man here. And then when you send it to this man here, he tries to understand what you have sent to it, the syntax, the semantics, using syntax, semantics, and grammar. And if it is correct, you understand, it gives you a result. And hopefully that result is what you want. But if it is not the result you want, you look at it again and you say, oh, this is not what I wanted. Then you fine-tune it and you send it and it sends you the correct. So it's an iterative process, you understand? So in case I forget, that's just that about that. So SQL programming, I think I jumped the slide, is for data access and processing. So it's not just only for you to just write and send, but basically you do a lot of things with SQL. So you access data that you have in this place through this language, and then you can process the data. That's what I referred to earlier as what you call ETL. For those of us that will be doing more of probably data engineering, you'll find out that SQL is a lifesaver. You find out that SQL will be your lifesaver. So having strong SQL skills would make you a better data engineer. And not only for people that are doing data engineering, even for people that are doing data analytics, it's going to save you a lot. I know after this class, we'll be doing a class on Power BI. And then maybe there you'll find out how really important and how really cool the skills you have learned here would be to you. So how is data used in tech? I would say data is used in tech a lot, basically. And then firstly, in software engineering, programming or development, you use data because take you back to the example of your school that you have registered with as a student. What you find out is when you register, you are sending, putting things inside somewhere. You understand? What you are putting there during your registration is your data. And how is that done? You write programs that interact, you understand, that interact with the database and is able to persist the data you have given to it inside that database, and you are able to call the data you have put inside that database. For example, look at your Facebook. Look at Facebook. You can scroll back to something you posted in 2014, something you posted in 2012, something you posted in 2008, 2009. And how can you do that, or why can you do that? It's because software engineering uses data basically. It's able to take all the data and persist them and allow you to call them as you need it to be. Okay, a data analysis or data analytics. So, well, we process data. I think that is why most of us are here, to make decisions. And then the questions we ask our data, we ask them how. So if you get something like you see that your revenue has fallen short by, let's say, 20% in this fiscal year, the question you ask is how? How did that happen? So when you ask the question, how did that happen? Then you begin to look at why did it happen? When did it happen? And what made it happen? So in the how did it happen? Okay, how did we lose 20% in revenue? We are not talking of profit here. How did we lose 20% in revenue this year? How? And when we ask how, we ask why. So if we ask how, now, okay, how did we lose? Okay, we were not able to sell. This was our top gross. This product was giving us our top gross, but this year, this product did not give us our top gross. We were not able to gross. We didn't give us as much revenue as it used to. Okay, that is how. Okay, why? Why is that product not doing what it's supposed to do? Okay, we had a shortage of raw materials to make that product that was our top gross in the second quarter of the year. So our competitors were able to take a section of the market away from us because we had a flaw in our supply chain. That is the why. Now, we talk about the what. The what is, okay, now what impact has this caused? Yes, we have shorted our revenue, you understand? But it has also impacted into our profits. And then the what now tells us, okay, Mr. A used to order 100 tons from us. It doesn't order 100 tons because he has asked 100 tons 5 times. And for each of the 5 times he has asked of 100 tons, the best we have been able to give him is we have been able to give him 40 tons. And so Mr. A now does not request for 100 tons from us as he usually does, but a request for 50. So our competitor has taken a chunk of what should be our revenue. And then the when did it happen? Second quarter of the year. I hope we are with me, guys. Hello, everyone.
Yes, we are.
Yes, we are with you, sir.
Okay, I hope we are understanding a few things. I know we are not touching the keyboard or so much today, but I hope you guys are understanding what we are trying to do.
Yes, we are.
Yes, sir. Yes, sir. Thank you. Please move on, sir. Thank you, sir.
The reason I'm trying to explain so much with what you guys can see around and what you would look at is because when you have an idea how this impacts anything or anywhere you have, you find it, I think, relatively easy to bring knowledge you have in one area to another area and be able to leverage on it successfully. Okay. So, in software engineering, there is what we call CRUD operation, which is create, update, and delete. And that is what they do with data when you go into Facebook and you register or you post something on Facebook. You notice what you have done is when you create a feed or a post on Facebook, you have created something. And now once you create that thing and you click on post, everybody is now able to see it. And now you can go back and you can update that thing, edit it, like your WhatsApp now. I don't know if you've tried it. You can actually literally edit messages you sent on WhatsApp to reflect another thing right now. Telegram has had that feature for a long time though. So what you have done is you have done what you call a CRUD operation. And that is essentially what happens in most of this web application or web development that people do. So we have 3 ends. We have the front end layer. That is what we all see, that is all shiny and glossy, what we interact to. And then there is a middle layer that communicates with the database. and then pulls out data from the database and styles it into the front end that we can all see. So for anyone who is aspiring to be a software engineer, there is no way you are not going to have to learn SQL, actually, because except you just want to design applications that people can see and not interact with. That is only when you will not be using SQL. But as long as you are designing applications that people are going to interact with, they are going to put in data and they are going to bring out data, either processed or unprocessed, style or unstyled, you are actually going to use SQL. Because that's like the de facto language for data processing, data analytics, actually. So, and while this is a huge step for us jumping into, you'll find out that in all areas of data science or data analytics, there is no one stage, you understand, where we do not interact with data, and conversely, where we do not interact with SQL. From framing the problem to solve, to communicating and visualizing results. No matter how good your algorithm is, no matter how beautiful the machine learning framework you are using is, how great it is, if your data is rubbish, the final answer it will give you is rubbish. You might not want to take it as what I've just said, but over time you will find out that data is the bedrock on which all of these things lie. And faulty data gives you faulty results. Good data gives you good results. There is no, how do I put it? There are no gray lines actually there. And most of the struggle you would actually go through is doing data wrangling or data cleaning. If you are doing data science and if you are doing data engineering, most of the struggle you will deal with is actually massaging data. That is data wrangling, massaging data into proper shape for people to use or to leverage for their tasks. And if you are, sorry, please, okay, let me call this person later. Sorry, please, can I pick this call?
Yes.
Hi, for those who joined late, sorry that I had to pick a call. He literally had to force himself to leave the office to do this class. So he already made a disclaimer at the beginning of the class that he may need to receive call from the office because he left late. So please just pardon this. Thanks.
Okay, sorry guys, I'm back. Okay. So you'll find out that data is actually the bedrock of all these things. And the more your data is good, the better you become, or the better the results you get. So for a data engineer, you will do data. For a data analyst, you are doing data, you are doing SQL. Even if you say you're a Power BI developer, and you get to places where you will now be talking about fact and dimension tables, you'll talk about how to properly structure your data, you'll talk about query loading, you'll talk about all those things. So SQL is, so even if you are visualizing, what you are visualizing is coming from one place. And oftentimes, if not most of the time, it's coming from a database actually. And if you are doing data science or data science at scale, what you are doing, what you are predicting is coming from a database. So there's no way you're going to run from SQL, sort of. And the great thing about SQL is actually quite easy to learn. It follows not all the rules of English language, but almost all the rules of English language. It has syntax, it has semantics, it has grammar. So, and the way SQL is worded, although we are not there yet, I think I'm jumping the slides, is you'll find it that it's almost as simple as you speaking English to any other person seated near you. And if you can't say it right, if you can't say the problem right, you're trying to solve in English language, you understand? Definitely your SQL query is mostly wrong and it won't run properly. Okay, so I think we are here. So I think I've talked about what a database is, but let us just go through this. So data set combines within DB as per query to extract required data. So you have all these data coming together and we put them inside one place. And then all this data you have here, that we have here, all of them all together as they are like this. Oftentimes in this scenario, all of them are about an entity or about a process or about, they are tied to something. And if they are joined together, then they are related. I think I explained that earlier. Understand? So, and all of them are combined into what we call a database. And then you can now talk to it and then it will answer you. So these arrows symbolize how they could be related to each other. You could look at this probably as an e-commerce application or an e-commerce store. Let me see if I can do some drawing here. Okay, let me see if I can do. So let me do some, okay, let's see if I can do some drawing. Okay, so let's talk, okay, I don't want to do this. Clear my drawings. Okay. So I do not want to do this. I do not want to write. I just want to. Okay, so let me just use my mouth to talk. So let's say we have a store, an e-commerce store. What we would have is we have people trying to buy things from the e-commerce store. And when they're trying to buy things, they're interacting with something. So we have a product they are buying to buy. And what they are trying to buy is going to have a price. And if it's Jumia, it's going to have somebody who is selling it. And then when you look at who is selling it, it's going to have a drop location. And then you also that you are buying it, you're also going to have a location. And if you look at all these things I've talked about now, you see that all of them are related to each other. You understand? And immediately you get on Jumia to buy, you're actually starting a process. So all the data you are keying in, I want to buy 5 bags of this and 2 bags of this and 3 bags of that. Everything is around the process of making an order. And all the data you key in from you making payments, it's still all about doing that very thing until the end of that process. Okay, so what do we use to now interact, which I have given you the expo before, is SQL. So SQL code would now be used to query the database, which is what we call a query is an SQL's, how do I put it now? A query is a statement written in SQL to pull information out of a database or to perform a crude operation on it. You understand? So a query is a statement written in SQL. Sorry, please let me take this call. My work people. Sorry guys, my apologies. Okay, so that's what SQL does for us. And oh, I have lots of messages here. I didn't check it.
Well, don't ignore the chat.
Okay. Okay. Okay, so I think I've talked about what a relational database, that database management system is. You understand? So when we talk about a relational database model, basically is the way we store data. A relational database management system is a database management system that stores data that are related. Now, the data now that you are putting there, or database now, the model, a model, how do I explain the model to you? Let me explain the model to you this way. When you have data put into something, or okay, let me put it this way. Let's say you want to build a house, so to say, and then you tell an architect you want to build a house. What they would usually do is they will draw something for you. Now, what they've drawn for you is not your house, but is what your house should look like. You understand? So if you're building a duplex, a bungalow, so what you have is a model. Now, a RDBMA is a way to describe how we are going to store data in the database and how those individual pieces of data are going to contain relationships to each other. You understand? I hope it makes sense. So if we talk about something like, let's say Jumia, and then I'm ordering products from Jumia, it means that the data might look disparate. Like I am moving from one screen where I'm trying to order to moving to another screen where I'm trying to make payments, and then I'm checking out my card and things like that. But all the data I'm inputting now, all of them need to be in a way for my order to be successful, and all of them need to be in a way that allows ease of processing, fast processing of data, even on their own back end. Understand? So in a relational database, we store data inside what we call a table. A table will have two things. A table will have a row and a column. Understand? A table will have two things, a row and a column. Now, the row now contains data about one single entity. One single entity. To explain better now, if you are in a university, you are not the only student of that university. You have many students in that university. But at each point in time, while you are still a student of that university, they know you as a student of that university because you bear something that the university has given you, which is your matric number, which is unique to you. Now, for each person now, if we put all your details in a spreadsheet, in an Excel sheet, we would have details of you like your name, your age, your sex, your house address, your next of kin number, your location, your blood type. You have all those things. All that information about each person is in one row, and we call a row an entity. Now, all those attributes about you, like your age, your sex, your blood group, your next of kin, all those ones are called attributes, and we call them fields. So an entity can have several attributes, but data from one entity does not mingle with data from with another entity. Just as you being a student of the school does not debar any other person from being a student, and anyone being a student does not debar you from being a student of an institution. Okay. Now, in a relational database, tables in a database are related to one another. So if I'm a student now, let me go here. Let us look at this. Now, I think this is a good way. Now, this is a relational database diagram called company. So if we look at this now, this is a table. Where is my mouse? This is a table. I think I could use this paste and draw. Okay, this is a table. This is a table. All these are tables. This also is a table. This also is a table. So all the data about this company are in tables. But when you look at all this data also, they are related to one another. And the way they are related is actually very simple. You find out that this department has department number. And here, this department number is what we call a primary key. We are going to get to all these things. But because of time, this is called a primary key. This one is called a primary key. Now, and then if you look at this table now, you see that this table is connected to this table. And if you look very closely, you see this department number. You will see it here also, right? You can see this department number here also. For each time you have a department number in this table called department, because it's a primary key, there is no two departments that have the same department number. Just as you're a student and there are no two students that have the same matric number. So this department number is a primary key. It is not null. You understand? It is unique and it is not duplicated in this table. But here, when you look at this table also, you have the same department number here. And in this table, this department number, we call it a foreign key. And the reason why we call it a foreign key is it references this table. It references this particular table that we have. So it's more like a lookup table. You say you want to look at something from something. You understand? Let's say, let me give you an instance. If you take a dictionary. No, I think this dictionary is a good one. No, a dictionary is not a good one. Okay, let's take a regular book. Any regular book you have, a novel perhaps. You understand? A dictionary is a good idea. If you take a dictionary and you open to the very back of the dictionary, I don't know whether they have dictionaries like that again. I don't know. You can look at listings of names, or maybe a book. You see, I think a book or a novel is a better idea. You look at it and you see names written with M. Let's say man, mammal, everything, and then you will see the exact page where that name is being referenced. Now, what you have done is you have created a key to search for something. So in this, that is what is happening right here. Not the same way, but should give you a better idea of what's happening here. So I can have in this department manager. So what it means, like I can have one department manager that manages several departments. That's what I can have, basically from what we have here. Now, if you look at this employee number here, you see this employee number, you see it has a key. Here it's a primary key. And here, this employee number is a foreign key. Because a department can have several employees. Right? A department can have several employees. I believe we can all agree to that. Hello?
Yes, sir, we are with you, sir.
I hope I've not lost you guys because you are very quiet in the class.
No, actually, you are doing this, sir.
Okay. I hope so. Okay. So, and then if you look at this from date also, it's the primary key here. And then you can see it connects to this place also. You see it's going down here. And then it is hitting this place. I think from date also has something it is joined here. Maybe it's not from date. It is written there. So maybe this is higher date, salaries, salary from date to date. So I think this is written here as higher date. I think it's written here as higher date. So it's still the same as from date, but it's written here as higher date, basically. And now if you look at title, okay, I think from date is okay. We have title here. We have two primary keys here. This is what you call, we have forgotten what we call it, but we have two keys here. And the keys we have here are moving here. So we have title, that is VARCHAR. I think we'll see the title somewhere. Where is it joined to? I think from date is here. Maybe as higher date or primary key. So we have all what I'm trying to say here is all of these tables are related to each other. So from one table, you understand, I can move into another table to pick out. So I can want to know the employee number that is, or the employee that that is in probably department, and the department is maybe something. From this table I have here, or this diagrammatic representation of what the table is, I can know who is where and how it happened. You understand? So we'll talk more about this later. Let me clear all drawings and then let me close this. Okay, I hope. Okay. So I think let me stop here today. I think we have a few more slides to cover, and then let me take questions. So anybody that wants to ask questions, please go ahead and ask your questions, and as much as possible, I'll try to take them, please. So anybody has any question, please.
Hello, sir.
Yes,
Okay, ladies first. Can the lady go ahead?
Okay, thank you. So thank you for the intro into SQL. It was really insightful. So when you mentioned like table, that this table is from a spreadsheet.
Yeah.
And I know that if we want to like put it into SQL, we have to like insert it and those other languages of SQL. So my question is, do we have to? What if we are working with a very, very like for example, for an e-commerce store that you mentioned now, like they have a big record.
Okay.
Are we like be manually inserting it? Like I feel that will make SQL very like tiring for me.
No. That's a good question actually, but no, not at all. So if you work with probably an e-commerce giant or something, or even anything like that, you'll be working as probably a data analyst. And then your work would be to analyze data. What you'll be doing is you'll be pulling data from SQL or using SQL to pull data from a relational database management system or what have you. Understand? The data entry actually in most of these cases or most of this are actually done by the people using the system. So for you now, you want to buy something on Jumia, you go to Jumia, and then it's you that will tell them you want to buy 4 rice or for maybe you want to buy a bag of rice, you want to buy a carton of Indomie. You are the one that is going to pick all those things, right? You are the one that is going to put in your card details. You are the one that is going to press your CCV. You are the one that is going to add all those things to cart. You are the ones that you are going to do all those things yourself.
Yes.
You, the consumer. So what you'll be doing is you'll be analyzing what the consumer is doing, not doing the same work as the consumer or doing what the consumer is doing. No. And in cases where there is data, there is a need for data entry, because yes, there is always a need to put in data for you to use data. Now, probably that will be not done by you if you are working with them as an analyst, You understand, data analyst. But if you're working maybe in merchandising, you understand. So you're maybe you have contact with a person who has a store, or so let's say you are a reseller with Jumia. What you do is, if you register as a reseller with Jumia or a seller actually with Jumia, is they onboard you onto their platform. They give you what they call access to a portal, and the portal they give you access to is very friendly. Then you tell them, okay, you take a picture of the clothes you want to sell. You understand? You put it there, and then you have an SKU that you put there. You have how much you want to sell it, you put there, and then all those details are there also. And if you're in merchandising, you can do that. Okay, maybe you are their contact person for stores, so you do it. But for you, you wouldn't be doing all that mostly. I hope that was explanatory.
Yes, sir. Thank you, sir.
All right, madam.
Yeah, listen. Hello.
I don't know what to
Hello.
do each other again.
Hello, Mr. Musayo. Can you hear me?
Yes, I'm listening to you. You can go
Okay.
ahead.
All right. Please, I want you to quickly go over syntax, semantics, and grammar again. Well, the difference between syntax and semantics, especially. Anyway, I didn't really get it.
Syntax is how you put it together. Basically, I think a dictionary will be the best person to explain this one to you. But basically, syntax is how you put it together. So like before there should be a semicolon somewhere. You understand? Let's say that you can't use present and past participle together in English language. You understand? That is just syntax. How you join it together. Basically,
Okay.
it's basically just the rules of English language. So syntax, how you join to semantics is how you now use the language, basically. Okay, thank you. I don't know if any other person has any questions.
Hello, sir.
Yes, I'm with you.
Thank you very much for the lecture. I don't know if you could help me explain more on foreign key and primary key. I didn't really get it.
Okay, so when we see something as a primary key, we are saying that that key is unique. And what we mean by it being unique is that that key is for that entity, no two rows or no two entities, so to say, have the same key. They are different. So just like you as a student, there is no other student in your school, if you are still in the uni, I guess you're out of the uni, that has the same matric number as you when you were a student. The same way, when we talk about the primary key, we are saying that only one person has this primary key and only one person uses this primary key. Only one person has this. That is, only one entity has this. No two use it. It is unique and it is not null. So by what we mean that it's not null is that primary key, what we refer to as the primary key, because it uniquely identifies an entity, it cannot be empty. It can, because that is the only way they can identify that particular entity as it being what it is. So it is unique and it is not null. So it cannot be empty. So that's what. So when we say a foreign key is while you would have in a table that has a primary key, you have it not been duplicated. That is also one thing about a primary key. In the table where it is found as a primary key, it is not duplicated. In the table where it is found as a foreign key, it can be duplicated. To give you an example now, in table, let's say we have a table called products, and we are selling jeans. We are selling you're a woman, so let me pick a jeans that you probably like. We are selling high waist jeans. And then the color is maybe what's your favorite color?
Blue.
Hello? Blue. Okay. So we are selling high waist jeans, blue, and it's your size. Now, and I am a seller. I would have a product ID for my jeans. That jeans that I am selling, I would probably have more than one of it. I have probably like 20. So what I would have as my entry is I would have a product key for that jeans. I'll probably have a storekeeper unit for that. And I have total quantity, like in stock, 20. So if you are now, that is the back end, I'm the seller, you are the buyer. So when you go to Jumia now to buy jeans from Jumia, and you see this particular jeans that I'm selling, and you like it, when you place the order for that jeans or you add it to cart, let's say you buy it, because there is a lot of process involved between you clicking and buying. Let's say you are buying that jeans, so to say. We are moving away from the carting process. What usually happens is this: the details of the jeans you have picked is going to be put in a database of items that have been sold. Are you with me? So what will happen is, if you buy 2 of those jeans, I have 20. In that table where that my jeans is, there is just only one product key, because I have one jeans. That jeans, I have 20 units of that jeans. So that jeans has one product key. That is in the product table. In the order table, you understand now. What will happen is you have placed an order for 2 of that jeans. In that order table, you have placed an order for, what I would have is, I will have, because it is the same jeans, but it is 2 units that you are buying now. Let's say you are buying one, don't let me confuse us. You are buying just one. So you buy one of that jeans. That product key is going to be there, referencing what you have purchased and the quantity you have purchased. Now, let's say another lady here goes there to buy the same jeans. Inside the order table also, that product key of the jeans will be there. The quantity you have bought will be there. In that order table, that product key is a foreign key. In the product table, in that order table, that product key is a foreign key. In the product table, that product key is a primary key. Do you understand?
Yes, sir.
No, do you understand? Like, actually, you understand it?
Yes.
Okay. So I don't. Okay, I'm listening.
Are you sure you understand? I'm guessing he does.
Yes, I
Okay.
Like, you actually understand what I'm saying, not you are trying to wrap your head around it.
Okay, I think, okay, let me just reiterate what I just learned now.
Okay.
Confirm that I understand it. If we have 2 tables, we have order table and we have product table. Now, in order table, the product key will be a foreign key. While
Come again, could you, your last statement?
I said in order table, key will be a foreign key. While
it will be a foreign key. Yes, go on.
While in product table, the product key will be a primary key.
You are just repeating me. That's not understanding, Auntie.
Okay. No,
That's not understanding. Okay. Why is it that in the order table, the product key can be duplicated and it cannot be duplicated in the primary why can it be duplicated in the order table and not duplicated in the product table?
Okay, because in the other table, we'll be having so many orders. So that's why we duplicate it as long as the orders keep coming. But in the product, we have just one product. That is, we have just one gene.
Okay. I think you have a fair understanding of what we are talking about. So now, what would happen is I should maybe take the time out, maybe before our very next scheduled class, I'll try to walk you through what happens when you place an order. so that you can better understand the flow of this primary key, foreign key, and composite key, as the case may be, how it happens in real life.
Okay, sir.
All right, madam. Okay, I don't know if any other person has any questions. No other questions? So would they find me again? Sorry, please give me a minute, please. I
think I can just come in here. Are there any other questions, please? Okay, 5, 4, 3, 2, 1, 0. No questions. Okay, I think we can. Oh my God, I think I was talking, but I didn't know I was muted. I don't even know the last thing I said before I muted myself. But I was saying, since there are no questions, we can call this a wrap. And I was saying we just got to the half of this. I was hoping we were going to finish this class in 1 hour, but apparently because the slides is 30 of them that we've worked on this slide, so it's like 30 slides. So, and the other half is supposed to be where we start going into the syntax, semantics, and all of that.
Please, can I say something quickly before we go? Sorry for interruption.
Okay, but you have not let me finish my statement. Please, can I finish my statement?
Okay, all right.
Yeah, so the remaining half of the class will be done next week, and it's looking like I was hoping we're going to cover like the essentials of SQL in 4 classes, but it might be 5 classes. So please just get ready to clear your calendar for that. But we're going to be meeting same time, except our instructor tells us that if he gives, I'll ask him during the course of the week what time is able to come through, but I'm assuming that it's going to be same time next week, like 5 p.m. And yes, I think that brings us to the end of this class. Mr. Shino, please go ahead with your question, or maybe.
Okay, thank you very much. What I wanted to mention is related to something you said when this class was going on about some of the members in the group having issues with the Excel course. I think that was what you were talking about. Instead of people going through recorded classes, that it's better to come to live classes like this. That I think you heard that some people have not even been able to find their way around probably some of the exercises from the Excel class. So based on that, I was thinking, because I think I also encountered the same thing too.